Problem set number 9 has its own unique challenges, so I like these questions. The square root we're going to write as to the 1/2. So we'll write t ln of t to the 4th to the 1/2. Square roots are so ugly, right? Let me just get rid of that. You can't do a square root for anything, but we can use the exponent rule now. There's one other thing you should notice, because you want to save yourself some trouble. Make sure you remember the natural log rules let you take the exponent right out. So I'll write this instead as 4t ln of t to the 1/2. Did you remember that? Tell me the truth. Write a comment in. Did you see that that was going to happen right away? Now we'll take the derivative. Cooper, it's fine. I can ask for a comment once in a while. I like to interact with the audience. 1/2 4t ln of t to the negative 1/2, just power rule, the input stays the same. Now we'll do the chain rule, which requires us to roll into a product rule. U prime v plus v prime u, because these are two functions of t multiplied. U prime is 4, v is ln of t, plus v prime, that's 1 over t, times u, which is 4t. So we see some cancellation here. This is going to go away. There's a 4 in both of these, so I think what we'll do is we'll write it as 4 ln of t plus 1, like that. And this guy on the left here can be rewritten back into his square root form so he can look scary to non-math people. That'd be 2 root, but there's a 4 here and a 2 here, so I'm just going to take them out now. And we'll just make it a 2 on top. 2 over the square root of 4t ln of t 2 ln of t plus 1. And that'll be the answer there. So number 1, not so bad. Number 2, that's a different story. Because arctangent and arcsine are never something I can remember, which means I have to derive them. And if I have an arctangent and I need to find the derivative, that horrifies me as a new calc student. So just remember that writing y equals the arctangent of x is the same as saying x equals the tangent of y. And now if I take the d dx of that, you're going to get 1 equals secant squared y chain rule dy dx. So your dy dx is equal to 1 over secant squared of y. So far, so good. Now the last little leap for this derivation, and this is where people get screwed up, so be careful, is to remember the identity that secant squared minus tangent squared equals 1. That's the only thing you have to remember other than sine squared plus cosine squared equals 1. Those are the only things you need to remember. So I can rewrite this as dy dx equals 1 over 1 plus tangent squared of y. Why would I bother to do that? Why would I take the time to rewrite that? Because we know that x is equal to tangent of y. So now I can get things into x form, which is what I want, and that's 1 over 1 plus x squared. So now we know the derivative of arctangent. We're halfway there because we need the arcsine ready and available to us. Let's move this guy up so we can just hang on to him for the problem itself. I'm never going to remember it as soon as I make it go away, so we'll just do it that way. Let's make this yellow go away a little bit. Okay. So the next one, let's write here y equals arcsine of x. I'm into that. Do you remember what to do first? Reverse into regular sine of y. Take the derivative. 1 equals cosine of y dy dx. Divide out, and we now know dy dx equals 1 over cosine of y. But the only identity we know is we need to use a trig identity is sine squared plus cosine squared equals 1. So I don't have a cosine, but I have a cosine squared equals 1 minus sine squared. So I can square root that. And then what we'll end up with here is dy dx equals 1 over the square root of 1 minus sine squared of y. Like that. That's what cosine is. So that's all just rearrangement. And why do we do that? Because this, we know x equals sine of y. So we can write dy dx equals 1 over the square root of 1 minus x squared. And again, we have the derivative in terms of x. That's what we want. So let's make this go away, because we all hate that. Let's make that go away. Boopity boop 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 on that. And let's bring this up here so we can refer to it in a minute. We're going to need it, I'm sure. So there's that. Okay. Now let's do the actual problem. See how you need to put your Legos together before you can build your tower? You got to collect your pieces and figure out what you're working with. We have y equals arctangent of arcsine of the square root of x. Obviously, this is going to become a chain rule. So let's find y prime. And that's going to be 1 over 1 plus arcsine of the square root of x. See how we didn't do anything but just put the input in that spot, and this is squared, isn't it? Just to be clear there, because it's not to the -1 to the 2. That's why I hate seeing it written this way. I don't like it. Okay, now what's next? Chain rule. We're going to be multiplying by the derivative of the inside, which we've already worked out, is 1 over the square root of 1 minus x squared, but it's the square root of x that we're squaring, so this should just become an x, times derivative of the inside again. That would be 1/2 x to the -1/2. So what we're going to end up with here is y prime equals 1 over 1 plus. And now you're going to see why I write arcsine of square root of x squared. This is all going to be on the bottom. So I'm just going to draw a long fraction like this. Root 1 minus x. I'll make sure this is in brackets here. That 1 plus needs to distribute correctly here to this guy. And then this is going to be 2 root x. Yeesh. And I believe we could probably combine the roots, but good Lord, like how much do you want to do in one question? I guess we could put it all together, but this is the correct answer. Okay, that was a lot, I know, but there's only one more in this problem set. You can do one more, and it's a fun one. It's implicit. There's multiple e's and y's and stuff. It's cool. So let's just have a look and make it, look, it's gone. That one's gone. It's all gone. The trauma's over. Let's find the derivative to this one. X e to the y equals y minus 1. What do you want to do? Take a derivative, of course. That's the whole goal. But what way do we take the derivative? d dx, of course. So this is going to be a product rule because y is a function of x and x is a function of x. So that's going to be a u prime v plus a v prime u. What's x for u prime? That's going to be 1. We know e to the y plus v prime e to the y is e to the y chain rule dy dx because it's a function of x. So you got a chain rule times x itself for the u equals dy dx minus what? Nothing. Because y minus 1, the -1 becomes a nothing for our derivative. So what can we do here? Let's move the dy dx's to one side. So I think we get dy dx. Let's write it as x e to the y minus dy dx equals negative e to the y. So I move this over here and I move this over here just to put those on the same side. And now we can factor it out like this. Minus 1 equals negative e to the y. Getting warmer. Now you can see, I'm sure, what we need to do is just divide. These implicit solutions are so cool. Look at that. That's going to be our answer for number 3. Implicit is so much fun when you get good at it. I hope you're able to follow the algebra in these, because I'm whipping through them kind of quickly, but when you're doing your test, you really need to be able to move at this kind of pace. So the trick is to know your trig, meaning your identities, your sine plus cosine equals 1 squared and all that stuff, but also your implicit with the chain rule. That'll conclude problem set number 9. That was pretty quick.